Okay, so let's go over how we solve these equations dealing with exponents. So let's look at problem 1 first. So we have 3 to the 8x equal to 3 to the 5x minus 6. And so here, the bases are both 3. So then when they're both 3, you can pretty much just ignore them and just set the exponents equal to each other. So we just set 8x equal to 5x minus 6, and then we just solve this. Let me zoom in to get a better visual. Take away 5x. From each side, we get 3x is negative 6. Divide both sides by 3. And we get that x is negative 2. All right, next we got 4 to the x equals 2 to the 5x plus 3. So here the base is 4 and 2. I'm going to put them in red. So the bases are two different numbers. So we can't simply just go straight up and set the exponents equal. What we want to do is make the bases both the same. So we're going to make them both 2 because 4 is equal to 2 to the 2. And we already have 2 on the left, so we can just leave it as is. And so on the left, we already have 2 on the right, so we just leave it like that. And so we have 2 to the 2 to the x on the left side and 2 to the 5x plus 3 on the right. Now we need to distribute this 2 exponent to that x, giving us 2 as the base, and on the outside we're going to have 2x. And then the right side stays the same. And now we have the bases both isolated. We both have the bases of 2 on both sides of the equation. So now we can just ignore them, and then we just set the exponents equal to each other. We have 2x equal to 5x plus 3. And then we can just solve for x. Take away 5x, we'll get negative 3x is 3. Divide by negative 3, and we'll get x is negative 1. Problem 3. Okay, another example of where we have bases that are different. So on the left side, we have a base of 8. And on the right side, we have a base of 4. So we got to make those bases equal. We got to make them both the same. And so what we want to think is, what number can 8 and 4 be raised from to like have the same base? And at this level, when you're first learning exponents, you're not gonna get very complicated numbers. Don't expect to get decimals. Just it's gonna be 2, because we know that 2 to the 3 is 8, and 2 to the 2 is 4. So we replace those with 2 to the 3 and 2 to the 4, but keep that all inside the parentheses. And then on the left side, we're going to distribute that 3 to the 5x there. And then we're going to have 2 raised to the 3 times 5x. You're going to multiply. So you're going to have 2 raised to the 15x. And on this side, make sure you distribute the 2 to both the 4x and the 7. So on the right side, we're going to have 2 to the 8x plus 2 times 7, so plus 14. Now you have both the bases isolated. See, now you just have 2's as the bases on both sides, so we can just cancel them, and we can just have 15x equal to 8x plus 14. Then we can just solve this guy for x. Take away 8x from both sides. We'll get 7x is 14. Divide both sides by 7. And yeah, I can fit it in here. X is 2. There we go. Moving on, moving on, moving on. Okay, now we got some more fun ones. Let's look at number 4. Here we have 25 to the x minus 2. And on the right, we have 125 to the 3x plus 1. So the bases are 25 and 125. Both of those can be rewritten as bases of 5. So I'm going to rewrite 25 as 5 to the second. And I'm going to rewrite 125 as 5 to the third. Everything else stays the same. And now from here, I'm going to distribute my 2 on the left side. So on the left side, I'm going to get 5 to 2x minus 4 being equal to. On the right side, I'm going to distribute that 3 to the 3x and the 4. So I'm going to have the base of 5 to the 15x plus 3. Don't forget to distribute the exponent to both of these because that's usually the common mistake that students will make. Now you have the 5s all isolated inside the parentheses, so then we can just set the exponents 2x minus 4 equal to 15x plus 3. And it just becomes your elementary equation. So we just take away 2x from both sides. We get negative 4 is 13x plus 3. Take away wait, hold on, what did I do here? Hold up. Multiplied wrong. I don't have a y note. Okay, well, I'm gonna go ahead and do 3 times 3 is 9x. Rewrite that as a 9. And what I'm gonna do is I'm gonna scribble that out because that's wrong. And I'm gonna rewrite this as 2x is equal to 9x plus 3. That's what I meant to do. Then I can take away 2x from both sides and 3 from both sides. I'll get negative 7 is 7x. Divide both sides by 7, and then I'll get that x is negative 1. There we go. That makes more sense. Water. All right, another one. Number 5. Okay, we got 9 to the x minus 6 is equal to 729 to the 3x plus 2. Okay, so we can actually go ahead and make them both into, well, let me put them both in reds so I can, the bases are 9 and 729. And 9, we're going to have them both be bases of 9 because you can actually write 729 as 9 to the third. 9 times 9 is 81, and 81 times 9 is 729. And you're like, well, how am I supposed to know that? The same way you're supposed to know that 11 times 11 is 121. I'll just put it that way. You'll just practice a lot and you'll get familiar with it, just like you are with your multiplication tables, hopefully. Now here we got that 3 and that x plus 2, outside the parentheses. So we want to make sure we distribute that 3 first. So what we have is 3x plus 6, like that. And let me put this away. And let me carry this over here. And what we're going to do is distribute that 3 to the 3x and the 3 to the 6. The left side stays the same. So we're just going to have 9, the x minus 6, equal to 9 to the 9x plus 18. Now we're all good to get rid of these 9s and just set the exponents equal. X minus 6 is 9x plus 18. Let's take away 9x from both sides. We'll get negative 8x minus 6 equals 18. Let's add 6 to both sides. We get negative 8x is 24. Divide both sides by negative 8, and we get x is negative 3. Oh, looks like we're running out of space here. Don't worry, I got you. I got some extra paper. Man, problem 6. So problem 6 is 4 to the 6 to the times negative x plus 2 equal to 8 to the negative 3x minus 4. So here the bases are 4 and 8. So we're going to rewrite those bases as 2 to the 2 and 2 to the 3. And the left or the right side, we keep the exponents the same. But on the on the left side, let's make sure we distribute this 6 to the negative x and 2. So we're going to get negative 6x plus 12 as our exponents there. And now we have to make sure we distribute this 2 to the negative 6x and the 12. So we're going to have 2 raised to the negative 12x plus 24 being equal to, here we have to distribute the 3 to the negative 3x and the negative 4. So we'll have 2 raised to the negative 9x minus 12. All right. Now we can cross out these 2's, and we just set negative 12x plus 24 equal to negative 9x minus 12. And then we just solve this for x. Add 12x to both sides. We get 24 equals 3x minus 12. Add 12, we get 36 is 3x. Divide both sides by 3. And we get that 12 is equal to x. No problem. All right, here we go. And the best ones you got. Fractions. Okay, so number 7. So we have 1/8 raised to the 2x plus 4. So the 1/8 is our base on the left, and the 16 is our base on the right. 1/8, you can actually rewrite that as 8 to the negative 1. Now, the thing is, you can't make them both have bases of 8. Don't confuse the 8 with being divisible, with 16 being divisible by 8. But what you can do is rewrite the 8 as a base of 2. So you can rewrite this 8 as 2 to the 3. So what you have is 2 to the negative 3. So, this may sometimes seem more like I'm doing extra work, but let me just do it in case you need me to see what I'm talking about. See, we have an 8 in here, and that 8 is the same as 2 to the 3. So you have 2 to the 3 to the negative 1, which is just 2 to the negative 3. So 2 to the negative 3 is 1/8. If you think about it, it's just basically 1 over 2 to the 3. And again, Once you catch on to this and practice this, you don't have to do it like this. I'm just breaking it down in case you are seeing this or not, not comfortable with this for the first time. But the 1/8 is 2 to the -3, but we still leave the 2x plus 4 as the exponent on the outside. And the 16 is the same as 2 to the 4th. So we have 16 as 2 to the 4th. This is all raised to the 4 minus x. And then we just distribute this -3 to the 2x and the 4 on the left. And so then we get 2 to the -6x minus 12. Let's distribute the 4 to the 4 and the -x on this side. So we'll get 2 to the 16 minus 4x. Now you can cancel out those 2's. And we just set -6x minus 12 equal to 16 minus 4x. And solve this basic equation, Add 6x to both sides, get -12 equals 16 plus 2x. Take away 16, we get -28 equals 2x. Divide by 2, and we get x is -14 as our final answer. Oof. Nice. All right, a couple more. Let me go ahead. I'm going to do problem 8 on a different paper, so I'm not cramming it all here. So let me write it over here. Problem 8. Two-thirds to the x plus 8 equal to 3/2 to the 2x minus 5. Oops. I'm freaking out. Okay. This is kind of like one of those trickaroos. 2/3 or 3/2, you can switch one of the bases, one or the other, doesn't matter. 2/3 is the same as 3/2 to -1. Or you can say 3/2 is the same as 2/3 to -1. So I'm going to rewrite the left side as, and we're really talking about this inside part here, as 2/3, or I'm sorry, 3/2 to the -1. All to the x plus 8. So let me put this in black, actually. So the base on the left is now 3/2. The base on the right is still 3/2. Two x minus 5. But let's make sure that we distribute this -1 to the x and the 8 first. So we're going to have 3/2 on the left side, all to the -x minus 8. Being equal to 3/2 to 2x minus 5. And now we have the same bases, which we can just then cancel out. And we solve the equation -x minus 8 equals 2x minus 5. Add x to both sides. We'll get -8 equals 3x minus 5. Add 5 to both sides. We get -3 is 3x. Divide both sides by 3, and we get -1 is x. All right. One more. Problem 9. Let's go ahead. Let's do it on this extra paper here. Problem 9. We got 5/4 to the 3x plus 5 equal to 16/5, or 16/25 to the negative 4x. All right, here we go. So we're going to make both the bases 5/4 because if you look at this, 16 is the same as 4 squared and 25 is the same as 5 squared. So we can actually rewrite 16/25 as 4/5 times 4/5. So we can rewrite 16/25 as 4/5 squared. Now, because 4/5 times 4/5 is 16/25. And now 4/5 is the same as 5/4 to the negative 1. So I'm going to rewrite 4/5 as 5. If I can write this 5 a little clearer. 5/4. What is going on with this pen? Let me try that again. I'm going to rewrite this 4/5 as 5/4 to the negative 1 power. Now, all that is all being to the second. And all of that is to the negative 4x. Again, I'm doing it in step by step in case you need it. But if you catch on to this quickly, you can see that 16/25 is just 4/5 to the negative 2. Oh, I'm sorry, 16/25. Yeah, it's just, well, it's just 5/5. It's 16/25 is 5/4 to the negative 2, which is the same as 4/5 to the 2. Let me just write it. So this whole thing ends up just being 5/4 to the negative 2. The negative 4x. The left side is still just 5/4 to 3x plus 5. So we didn't have to change anything on the left side. And then all we have to now do is make sure we distribute this negative 2 to the negative 4x. So then we get 5/4 to the 8x is equal to 5/4 to the 3x plus 5. I'll probably separate that. And then we just can cancel out the 5/4 finally, because now we just set 3x plus 5 equal to 8x. Take away 3x, you get 5 is 5x. And then x is just 1. And there you go. That's our answer. So hope that helps. Let me know if you have any questions or any comments. Feedback will be helpful. I know exponents can be very confusing the first time you see them. And sometimes I don't know if I show too much work or not enough work, or I never know because I've been doing this for hundreds of years. So, so let me know. And of course, give me a like or subscribe if you haven't yet. And I'll see you guys in the next video.